I decided it would be a good idea to work one more of these homogeneous equations, but this one with initial conditions. And so here it is. And this is, if you're keeping score, this is in this book, Morris and Tenenbaum and Pollard. It's on page 220. It's problem number 34. So page 220, problem 34. And it reads, y double prime minus 4y prime plus 20y equals to 0. And the initial conditions are y at pi over 2 equals 0 and y prime at pi over 2 equals to 1. Now it's typical in these problems for the two initial conditions, and we need two initial conditions to solve for those two constants we keep getting. It's typical to have one associated with the first power of our function and one, rather the function, and one associated with the derivative of the function. And you know, for example, this might be position and velocity. So, and normally these initial conditions are y at 0 equals to a number, y prime at 0 equals to a number. Seeing the pi over 2's there, this tells me that this probably involves sines and cosines and complex numbers. So anyway, let's go about this. Now our characteristic equation is going to be m squared minus 4m plus 20 equals to 0. And then solving that, I'm going to need the quadratic formula, I believe. So m is going to be minus b plus or minus the square root of b squared minus 4 times a times c, all divided by 2a. And that gives us positive 4 plus or minus, this is going to be 16 plus 80, so that's 96. Square root of, no it isn't, I'm sorry. 16 minus 80 is negative 64. Let's get that up there. 16 and then minus 80 is negative 64. There we go, that's better. So I've got 4 plus or minus the square root of negative 64 divided by 2. The square root of minus 64 is 8 times I. 8I over 2. And so that ends up being m is 2 plus 4i. There we go. So divide the 2 into those terms. We have 2 plus 4i. Alright, let me erase this, make a little more room. I think I forgot the plus or minus here before I did all that erasing. So actually it's 2 plus or minus 4i. And we always get two roots with quadratic equations. Now then, if we go with the cosine and sine formulation of this, then our solution is going to be y equals to e to the 2x parentheses cosine of 4x plus, yep, I made a mistake, didn't I? Forgot my additive constant. Try that again. E to the 2x parentheses c1 cosine 4x, so I needed that constant there, and then plus c2 sine 4x. So that's the formulation with cosine and sine in it. Alright, now if we're going to need the first derivative for our initial conditions, so let's just go ahead and do that. So y prime is going to be, and here I've got a chain rule, I'm sorry, a product rule going on. So derivative of e to the 2x is 2e to the 2x times this whole parentheses, c1 cosine 4x plus c2 sine 4x. And then we get another term, we have to take this derivative times e to the 2x. So plus, this e to the 2x, parentheses, this derivative is going to be, derivative cosine is minus sine, then we have the chain rule operating on 4x, so it's minus 4 c1 sine 4x. And then here it's going to be plus 4 c2 cosine 4x. Well, there we go. So we have all that ready to plug in the initial conditions, and what are we doing? We're trying to figure out what C1 and C2 are, the two constants. So let me erase this, and we'll use this one first. Y at pi over 2 equals to 0. So this is e to the 2 times pi over 2. We don't see that every day. Parentheses, C1 cosine 4 times pi over 2 is what? That's going to be 2 pi, isn't it? Cosine of 2 pi. And then plus C2 sine of 2 pi. Well, some nice things happen here. Sine of 2 pi is 0. And then cosine of 2 pi is 1. And here the 2's cancel. So I have e to the pi times C1 equals to 0. So remember that y of pi over 2 is equal to 0. This whole mess equals to 0. Well, e to the pi is a number. I don't know what it is, but it's a number, times C1. That means that C1 is equal to 0. If C1 is equal to 0, then that wipes out that part and wipes out these parts with C1s in them. So maybe I should have saved myself some trouble and not done this derivative until I had figured out the C1 was 0. That may have been a little better way to do this problem. Alright, now I'm going to plug in y prime at pi over 2 down here, realizing now I can ignore these two terms since C1 was 0. So y prime at pi over 2 would be 2e to the pi, and I've got C2 sine 2 pi, 4 times pi over 2, 2 pi. And then we have plus e to the pi, plug it in, and then over here it's times 4c2 cosine of 2 pi. And this was equal to 1, wasn't it? Alright, so that's a little messy. I hope you're following all this well. But we can do some cleanup here. Sine of 2 pi is 0. So this whole term is 0, it cancels. And over here, cosine of 2 pi is 1. So it looks like C2 will be 1 divided by 4e to the pi. So C2 is 1, solve for C2, divided by 4e to the pi. 4e to the pi. There we go. So I'm going to erase most of this and write the answer to this problem down. I got y equals to e to the 2x times sine 4x divided by 4e to the pi. And our book combines the e's together and makes it 1/4 e to the 2x minus pi. 2x minus pi, and then times sine 4x. So that's the form I believe the book has it in. Let me just make sure. Indeed it is. So, good sign. Anyway, there's problem number 34. Now I'm going to move on to the non-homogeneous problems.